Hello everyone, it's Michael again. So today we are going to do a walkthrough in this lab querying data by using Athena. Lab overview and objective. So Sophia is happy with the proof of concept POC that you created for Amazon Simple Storage Service, Amazon S3 Select, and the team is learning how to use it. However, one of the data scientists, Mary, would like to perform more advanced queries on comma separated value CSV data. She often works with large datasets that are stored across multiple CSV files, and she can't use S3 Select with multiple files. Therefore, she would like the ability to query multiple files in the same S3 bucket and aggregate the data from these files into the same database. She also wants to be able to transform the dataset data metadata, such as column name and data type declarations. This information is part of the dataset schema when the data is stored as a relational database. Through some discovery, you learn that Amazon Athena provides this functionality. You explore Athena and its capabilities to see if you can address Mary's needs. Athena is an interactive query service that you can use to query data that is stored in Amazon S3. Athena stores data about the data resources that you query. You can store your queries for reuse and you can share them with other users. In this lab, you will learn how to use Athena and AWS Glue to query data that is stored in Amazon S3. After completing this lab, you should be able to do the following. Use Athena Query Editor to create an AWS Glue database and table. Define the schema for AWS Glue database and associated tables by using the Athena Bug Add Columns feature. Configure Athena to use a data set that is located in Amazon S3. Optimize Athena queries against a sample data set. Create views in Athena to simplify data analysis for other users. Create Athena name queries by using AWS CloudFormation. Review an AWS Identity and Access Management IAM policy that can be assigned to users who intend to use Athena named queries. Confirm that a user can access an Athena named query by using the AWS Command Line Interface, AWS CLI, in the AWS Cloud9 terminal. So this lab is about an hour and a half. Here's the scenario. So in this lab, you will assume the role of a member of the data science team. You will build a POC using AWS Glue and Athena to analyze the data that's stored in Amazon S3. You want to experiment with Athena by accessing raw data in an S3 bucket, building an AWS Glue database, and querying this database by using Athena. You also want to determine if you can scale this solution so that others on the team can have access. Mary is part of the IAM group in AWS for Data Science team and has similar access to the S3 bucket. AWS Glue database and Athena. So, however, you limited her access to prevent unnecessary creation of resources. This follows the principle of least privilege, where an administrator limits access to AWS services and resources based upon what permissions are necessary to perform a specific job or task. In one task, you will use an IAM user to test the ability for a data science team member to run Athena managed queries. The IAM user was created for you. The users belongs to an IAM group that has a policy attached to the 5 permissions. You ask Mary if she has a field sample dataset that you can use for your experiments. Mary provides access to a dataset that contains taxi trip data for 2017. You will use the data for your POCs. The following diagram illustrates the environment that was created for you in the AWS at the beginning of this lab. So it's right here. Here are some tips to review the CloudFormation templates that build this environment. After logging into the AWS Management Console, navigate to the CloudFormation console. In the navigation pane, choose Stacks. So by the end of the lab, you will have created an additional architecture that is shown in the following diagram. The table after the diagram provides a detailed explanation of the structure in relation to the tasks that you will complete in this lab. So this is infrastructures after you complete this lab. So right here, so the first task, we have 7 tasks, and this is going to the details. Okay, so let's start our first task. So our task 1 is create and query an AWS Glue database and table in Athena. So your first task is to use SQL statement to define a schema for a table that can be used to work with the sample CSV data. In this task, you will do the following: specify an S2 bucket for query result, create an AWS Glue database by using the Athena query editor, create a table in the AWS Glue database and import data, preview the data in the AWS Glue table. So first of all, in the AWS Management Console, go into the search box to the right of services and search and choose the Athena and open the Athena console. Specify an S2 bucket for query result. So when you use Athena, you must specify an S2 bucket to hold the result for any queries that you run. A bucket was created for you, so complete the following step to configure and use it. So in Athena console, choose Explore Query Editor. Explore Query Editor. So let's launch query first. Where is it? Explore Query Editor. So in a Athena console, choose Explore the Query Editor. Console. I don't see any console. Let's see. Explore the query editor, choose setting tab. Alright, I guess this is in setting. In the query result and encryption setting section, choose manage query result and encryption setting. Query result and encryption setting right here. Encryption setting, choose manage. Okay, manage, and then for locations of the query result, choose browse S3. browse S3 location. Why is browse S3 right here? Choose the bucket that was created for you and then choose select. Alright. Keep the default for the auto setting on the page, choose save. Alright. Now at this time, you are required to specify an expected bucket owner. Now create an AWS Glue database by using Athena query editor. So choose the editor tab in the query one sections, editor tab just in the query one query sections. Enter the SQL command here. So create database taxi data. So we create the new database name taxi data, and then choose run. Awesome, it's running. Okay, so it's run successful. The message query successful display in AWS Glue database name taxi data is created. Tip is to confirm that the database was created in the AWS Glue. Open a new tab and navigate to the AWS Glue console. In the navigation pane, choose database. Okay. Open a new tab, and I'm going to search for AWS Glue. Inside AWS Glue, I want to choose the databases. Where is it? Maybe right here, databases. Awesome. Databases. Taxi database is listed on the page, so right here it's listed, so it's work. Awesome. Next you will create a table in the AWS Glue database and import data in the Athena console. In the table and view sections on the left, choose create and S3 bucket the data, table and view. Create an S3 bucket data. Yep, S3 bucket data, and configure the following. For table name, enter yellow, and then for description, we're going to have a table for taxi data. Awesome. And database configuration, select choose an existing database and then choose taxi data from the drop down list. Database configuration, so choose an existing database and we'll choose the taxi data. For the drop down list, then location of the input data set, copy the following link into the field. This is the location of input data set. This is the location of input data sets right here. Go to paste it in here. And then encryption, keep the default setting, which is not selected. Let's see, encryption was encryption, but encryption should be untouched, which is not selected. For the data format, choose CSV. Okay. Probably data format. What about data type? Table type? No, table type. Just data format CSV. Where? CSV. Alright. Data format. Right here is CSV. And in the column details section, choose bug add columns. Column details. Where is column details? Right here. Column details section, choose bug add column. Bug add column. Awesome. So note in this features provide the ability to quickly add metadata to the table, such as column names and data type declarations. So the pop box, copy and paste the following text and then choose add. So we're gonna add those value in here and then add. Awesome. So we add it in here. What we'll do next. So the column name and data types populate in the column detail sections. In the preview table query sections, view the query table query text which matches the following text. Preview table query. Let's see. We have the string times string, int, decimal, things like that. Here, yep, it's look the same. Yeah. So note that the data is not encrypted. 30 is a data serialization format, and the 30 properly specifies that the data must be comma delimited, which is okay, city. What is city right here? Okay. So now choose create table. Now we create our table. Oops, something unable to verify if the selected bucket belong to your current regions. Acknowledge that this location of input data will incur data transfer charges. The message create successful display. So we acknowledge that and then choose create table. Awesome. So now that you have so create and message query successful display. Now that you have a table with the taxi data and you can write query to retrieve data from the data source in the Amazon S3. Now preview the data in the AWS Glue table. So in the data section on the left for database, choose taxi data. AWS Glue table. In the data section on the left, is there any data section on the left right here? Jobs, data sources. Is it this one? I think they talk about the other one, but the data sources they have this. So for database, choose taxi data. They do meant the other one right here. So database with taxi data right here in AWS Glue. Awesome. In the table section, to the right of the yellow table, choose the ellipse 3 dot icon and then choose preview table. Choose preview table. Wow, where is it? Is it right here? Because the instructions seem like outdated. The GUI seem different. So pretty sure this is preview the data, the table. Then the results section display the first 10 record of the table. All right, this is display of the table right here. This is what they're looking for. Before continuing, at the top of the query editor, close the open queries by choosing the X icon on each query tab. When prompted, choose close query. Very interesting. What we do now? Does that mean we go to the notebook editor? No, not this one. How about this one? Nope. Workflow, work group, primary, capacity, data source. Oh, very interesting. So choose tax table, yellow, 3 dotted line. I don't see any 3 dotted lines. Click in here. I see this first 3. The result section display the first 10 record of the table. So in here is a preview data in AWS Glue table. So in the data section on the left for database, choose taxi data. Seem like they talk about this one table. So databases and then table to taxi data. Right here we're gonna view data quality. Go back again. Yellow taxi data. If we choose taxi data 3 dotted line, I don't see any 3 dotted line in here. So if I click into taxi data, nothing happened. Data table. If you click into yellow, then we have the entire table right here. But they talk about like now that you have created a table, so preview data in the AWS Glue table. Right, AWS Glue table. So in table section, to the right of the yellow table, choose ellipse 3 dot, then choose preview table. So let's say I go back. All right, go to this, and we get started. Back here in the data table, right here, we choose this, no three dotted line right here. What we're going to do is click into the taxi data, and what we're going to do is click into it and it's view the table, but then that pretty much it. Let's see what they want afterward. So before continuing, at the top of the query editor, close the open query by choosing the X icon on each query tab. When prompted, choose close query. You can only have 10 active query in Athena at a given time, so you must manage these accordingly. Right, so choose stop query if there is any. Let's see any queries here. What about up there? Taxi data source. We'll go to Athena, launch query, right? Launch query, yeah. Query 2, query 1. What they want us to do. So before continue, at the top of the query editor, close the open queries by choosing X icon on each query tab. When prompted, choose close query. Okay, what they meant is probably this, right? Yeah. So right here, down here we have the table and stuff. 0. Run. We will rerun that. The query start. Recent query. Interesting. I see only a 3 dotted line in here, but we able to view it already. So now they want us to just close this query. So close query. We close all the query here. Yeah. So go back. So summary task 1. In this task, you create AWS Glue database and table by using the Athena query editor. You connected an Amazon S3 dataset to the table and define the schema for the table by using the book add columns features. After you create a table, you learn how to preview the data by using the preview table features. And then Mary can now use more advanced SQL queries and custom column data types for the CSV files that are stored securely in Amazon S3. This wasn't possible when using S3 selected alone. So for task 2, we're going to optimize Athena queries by using buckets. When you work with large datasets that are spread out across multiple files, two major goals are to optimize query performance and to minimize cost. Cost for Athena is based on usage, which is the amount of data that is scanned. The price vary based on our regions. So 3 possible strategies that you can use to minimize your cost and improve performance are compressing data, bucketizing data, and partitioning data. Compress the data by using one of the open standard for file compression such as gzip or tar. Compression result in the smaller size for the dataset when it's stored in Amazon S3. The cardinality of your data also affect how you should optimize your queries. For more information, see the cardinality SQL statement. There are 2 options to optimize based upon high or low cardinality. These are bucketizing data for high cardinality with data store records in distinct buckets, not to be confused with S3 bucket based upon a share value in a specified field. Consider bucketizing data as part of the pre-processing phase of your data pipeline. In this lab, data for a single month will be bucketized separately from the original data set, which contains data for an entire year. These strategies will help you to optimize performance. Partitioning data. You can also use partition to improve performance and reduce cost. Partitioning is used with low cardinality data, which means that fields have few unique or distinct values. So in this task, you will experiment with bucketizing data to optimize the Athena queries. You will complete the following sections. Create a table named Yan to hold bucketized data. Compare how long it takes to run a query against bucketized data for January 2017 and how long it takes to query the entire datasets for the January 2017 data. So create a table for the January 17 data. So in the Athena query editor, choose Edit tab. Okay, so in the Athena query editor, choose Edit tab, launch, add edit editor, Edit tab. To open a new query tab, choose the plus icon on the right side of the query section and the close out O1, right? So let's say it's right here. That's not what we want to paste in. So copy and paste the following into the query, a tab, and then choose run. Okay, so copy this query here, and then run it. Awesome, it's run successfully. Now, the message query successfully display. Athena created a new table named Jan, which contains the taxi data for only the month of January 2017. The table is listed in the table section on the left. Analysis. In this step, you create a table to store the data for only January 2017 by using this study. The values in this dataset all have pickup timestamps, and almost all the timestamps are unique for each record. Meaning that records have high cardinality, but also have January in the month column, so you can use bucketizing. The January data is stored in the separate file in Amazon S3 from the file with the full data set. In the following step, you will investigate whether bucketizing these records in the separate file improve performance compared to the querying for January records in the full data sets. So run the following query in the yellow table, which has data for the entire year. The data is not divided into month bucket. Okay, so what we're going to do is run the following query on the yellow table. Where is the yellow table? Data sort, catalog, taxi data, yellow table. Wait, what? So they want to run those query on the yellow table, which has data for the entire year. The data is not divided. So they want us to run this on the yellow table. So I don't know, just going to open a new query, right? And then run it. Fail the table like this query against default database. Unless qualified query, please post error message for contact. Cannot run in here. So what is going on? Close the query. How about run this again? Alright, run this again. It's worked. Very interesting. Let me go back. Go back. Very up there. Go up here and create the yellow table. Alright. Go back here. New query. Whatever. I run it here, right? Alright, and then after that, I'm going to create this. Wait. They want this to be on the yellow table. Does that mean I have to go into the glue table in order to do that? It is schema. No, I cannot do it right here. It's a database table. January, right? January. No, go back. View data quality. What we're gonna do? Like create data quality rule. Run history. No. What if I go in here? Result. What I need to do? Refresh. Right. Refresh this to see what happened. That's January. So create. S3 bucket table. Create table. I don't know. We'll run this. It's not working. Why? It's query against the default database unless qualifies. Does not exist. This does not exist. What happened? They are deleted. Very interesting. I don't know. There's only one table. So maybe a create table right here. Run. There's only one table right here, it says so. S3 bucket. This is glue. Table. We have two tables up right here. So what they're talking about? Table data. Go to yellow. Actions. View data. Edit table. Edit schema. Edit table. Maybe. Edit table. Edit schema. Edit schema. What are we doing? Edit schema as JSON. Wait, what do they want us to do again? So run the following query on the zero table, which has data for the entire year. The data is not divided into monthly bucket. Interesting. So do I just like open a new query, right, and then run it here? It just says that it existed. It's here only one table. So view. What do we need to do? Just only separate as the buckets for the query table. The date is not divided monthly bucket. So do I go back in here? It's a yellow, right? And then I run another query. How about this? I don't have that table up there. So how I am able to do that? Default database default. How about taxi? Oh, right here, yellow. Oh, maybe that's the one I'm supposed to do, right? Place back in here. Run again. It's yellow. Uh, hope it's working. Good. I switched the table up there. So taxi table and default. So I choose taxi, and now I have a yellow table up there. Okay, that's work. Awesome, awesome. So the message is successful display and the note, the runtime and amount of data scanned for the query. Now you'll be able to compare by running a query against the January table. So run the following query on the January table. Oh, I have to switch the table around. So this is that. So I'm going to default. Default is going to be different. So now I'm going to have this query run on the January table. Let's see. It is loading. Yes, of course, it's running. Let's see what the query do. So query is select count as a number of trips. So to sum total as the total fares. Pick up trip dates from January, and group by pickup. Awesome. So none the runtime and amount of data scanned for the queries as you see, and much less data is scanned when the query is performed against the table that on is contains the January table analysis. So putting data in the separate bucket works when you have data that has a high degree of cardinality. Cardinality refers to the number of distinct records in a database. In this example, the pickup field has a high degree of cardinality because every trip has a specific day and time. So summary, it is tasked to create a table for January 2017 data. You learn how to optimize queries by using various strategies such as dividing data into multiple buckets and partitioning data. To accomplish this task, you first ran a query on data and was not divided into buckets and used this query as the baseline. Then you ran a query on January 2017 data, which was divided into a separate bucket and compare the result to the database. Now, we need to optimize Athena queries by using partitions. So if you're interested in querying a field with low cardinality, which means that the field has a few unique values, you would partition the data instead of using distinct buckets. In some cases, your data will be partitioned by another process. To find the most efficient approach, you will try to partition the data by using the pay type field in a specific query in Athena. The pay type field stores the type of payment by using the following code: 1 for credit card, 2 is cash, 3 is no charge, 4 dispute, 5 unknown, 6 avoided trips. Because of the set of possible values is limited, pay type is an excellent column to use to create partitions. In this task, you will create tables as functions to partition the data. You will also specify the columnar storage format. You can store data in Athena with the patches, packet, or optimized row columnar ORC formats. Columnar storage format compress the data, which will further reduce costs for your queries. In this task, you will experiment with using partitions with your queries. You will complete the following steps: create a table that is based on the patches, packet format, and use the pay type field as a partitions. Compare the time it takes to run a query against the yellow tables database for record with pay type 1 credit card to how long it takes to query the partition table that was built with the Apache's packet format. To begin, you will create a partition by running a query to select the data that you want to use for a partition and to indicate a storage format. To create a new table called taxidata.creditcard that is partitioned for paid time 1 credit card transactions, run the following query in a new query tab. Create table taxidata.creditcard with format set packet as select from yellow where part type is equal to 1. The runtime and data scan values are similar to the following: type in queue to 51, runtime 28.572, data scan 9.32 gigabyte. Now you will compare the performance of running queries on the non-partitioned data in the yellow table and partitioned data in the credit card table. So First of all, we need to create a new table called taxi data that credit card that is petitioned for part type 1. Run the following queries in the new queries tab. So that's first thing first. Let me delete some of the query. I'll just leave it there. Just run a new query. Oh, choose default. No, not default. Run on taxi data. The runtime data scan values are similar to the following. So 251 millisecond, runtime 28 second, data scan is 9 gigabyte. Successful. Yep, we'll get it right here. So now you will compare the performance of running queries of the non-partition data in the yellow table and partition data in the credit card table. So to create the non-partition data in the yellow table, run the following queries in the new queries tabs. Make sure it's yellow. Okay. Right here, yellow table. Run it. Okay, so run it already. So the runtime should be similar like this. Awesome. So we have it right here. So to query the partition data in the credit card table, run the following query in the new query tabs. Run it. Awesome. So analysis, so we have the similar metric right there. Analysis, notice that the result of each query are the same, but the query on the partition data looks significantly less time because scan less data. Remember that you are charged for the amount of the data scan for each query. So since the last query scans less data due to the user partitions, your cost is reduced. For task 2 summary, so in this task you partition a data set where the pay type field contains a specific value. Then you run queries on non-partition and partition versions of the data and compare the results. So task 4 is using Athena views. You might have noticed that Athena can create the views. Creating and using views with data can help to simplify analysis because you can hide some of the complexity of queries from users. Athena support running only one SQL data statement at a time, but you can use a view to combine data from various tables. You can also use views to optimize query performance by experimenting with different ways to retrieve data and then saving the best queries as a view. In this task, you're going to do the following: create the view to calculate the total the value of taxi fares that were paid with a credit card. Create the view to calculate total dollar value of fares that were paid with cash. Retrieve all records from each of these views. Create a new view that joins the data from these two views. Preview the results of the joint. So to create the view of the total dollar value of fares that were paid with the credit card, run the following queries. Okay, so we run these queries. Awesome, successful. The runtime data scan value should be similar as this. Should be here. Cool. To create a view for the total dollar value of fares that were paid with cash, run the following queries. Let me delete some of the previous queries so we can add more queries. Okay. Pretty good. Let me see. Cast strip, right? Yep. Notice that the view section on the left now lists two views that you created: CS strips and cast strips. Right here. Awesome. To select our record from as cast strip view, run the following queries. Okay, so it's running. Scan, data scan. Awesome. The runtime of the data scan was similar to the following, which it is a little bit faster on my machine. So to select all record from the cache group to view, run the following command here. Okay, it's loading. Data scanning. Awesome. So here's our metric. So the runtime of the data scan values is similar to the following. Now that you learn how to create a view that joins data from two different views, you will use this view, new view, to find out the total revenue from the credit card payments compared to cash payments for two vendors. So to create a new view that joins the data, run the following queries. Okay. Close the old query, add new one. Now let's run it. Awesome. So preview the results from the Jones in the view sections on the left. To the right of the compare page view, choose the ellipsis icon, and then choose preview view. View on the left, ellipsis icon. Oh, so on the previous section we should see something like this, but either way it's the same thing. Let's go back to our view here. So what we can do, in the view section on the left, to the right of the compare page view, where is it? To the right, right here. Choose the ellipsis icon and choose preview view. Right here. Open query. Awesome. So that's the one right here. Oh, I see. If the prompt is about opening the query, choose open query. The result display similar to the following. Result display. Yep, it is. Wow, interesting. So on the very first one, I should have like choose like preview table here by using this three dot up there. So it is like this. See the first 10 result. Awesome. Yeah. Oh, now I see it now. But for this task we go to preview this right here. Let's go to run queries. We have like what is right here. Awesome. As it show here. So task for summary. In this task, you learn how to create views in Athena. You create two views to calculate the total revenue of taxi fares that were paid with the credit card and paid with cash. You also learn how to use a view to join data from two other views. The skill that you learn in this task will help simplify the analysis of data by using Athena. So for task 5, creating Athena name queries by using the CloudFormation. So data science team want to share the queries that they built by using the taxi dataset. The team would like to share with other departments, but also those departments use other account in AWS. Other departments have less experience with AWS, so the data science team would like to simplify the process of using Athena for other departments to use. Note that in this lab, you will focus on creating the CloudFormation template to create a name queries in Athena. The template will not create the AWS Glue database or the table and data within it. You want to simplify the process to deploy queries. After some research, you determine that the best solution is to use the CloudFormation template for each query. The template can be shared with your other department and deploy as needed. First, you want to experiment with building an example query and testing it by using Merit IAM users. If you are successful, you will share the template with other departments. So review and run example query. Mary provide you with the following example queries. So this query used the yellow table for the taxi data database. The query does the following actions: select all record in the yellow table, from yellow, so right here, a table where the total charge is greater than or equal to $100, display the record in the descending order by the total field, right? Order by total field descending, DESC. So the most expensive strip is display first in the result. Display the following field for the result record right here. Listing, pay type, fare, tips, toll, surcharge, total. Run this example query in the Athena query editor. Okay. So I'll go back here and let me delete one of the queries so we have more query to run. So let's start running this query. We should see all of this here from this yellow table for where the total is more than $100 by descending order. Yeah, so our table is going to contain like distance, pay type, fare, tips, and toll, surcharge total from the yellow table, where the total is 100, more than equal to $100. Order, so the order should be descending. So we have it right here. Surcharge total, awesome. So let's go back. Yes, so it looks something similar like this. The query is working at design. Now focus on creating the CloudFormation templates for the queries so that it can be reused and shared. So navigate to the AWS Cloud9 integrated development environment IDE. So in the AWS management console, in the search box next to service, search for and choose Cloud9, and then open Cloud9. So let me open this. All right, go to Cloud9. Go to Cloud9, and then after we are in the Cloud9, choose Cloud9 to open the AWS Cloud9 console, AWS Cloud environment list. So for environment name Cloud9 instance, choose open IDE, Cloud9 instance, choose open Cloud9 IDE. This part will take a few moments. We are in. Awesome. So now we are in a new browser tab open and display the AWS Cloud9 IDE here. So next, what we will do is we will create a new CloudFormation template. So in the AWS Cloud9 IDE, choose file and then new file, right? And then save the empty files at this name right here, but keep it open. I want to save it. I want to change the name to Athena query. And we have it. Now copy and paste the following code into the file and save the file. Paste it in here, save it. It's saved. Examine the command to see what is created, and the command create a CloudFormation template named the Athena query.cscf.yaml. This template will create a CloudFormation stack that does the following: create an Athena query using pre-existing database in Athena, name taxi data. Note that for another user to use this template, the taxi data database must already exist in their AWS cloud. So name the query phrase over $100 US. Use the example query that you tested previously in this task. Output the details of the query to output tab stack once it is created. Okay, so it is what it is now. What we're going to do is to validate the CloudFormation templates, run the following command in the AWS Cloud9 terminal. Yes, so we have here parameters, empty parameters. Note that if you receive an error that say YAML were not well formed, check the value of the name of the queries and also the tab and spacing of each file. YAML documentation require exact spacing, and parsers we encounter error if the space isn't matched. So if it is validated, the following output should display, which is we got it. Important, don't go to the next step until the template is validated. So now you will use the templates to create a CloudFormation stack. A stack implement and manage the group of resources that are outlined in the template. With a stack, you can manage the state and dependencies of those resources together. think of a CloudFormation template as the blueprint, then the stack is the actual instance of the template that is registered in AWS and actually create the resources. To create a cloud stack, run the following command here. Awesome. So if the stack is validated, the CloudFormation Amazon resources name ALN displays in the output is similar to the following here. The CloudFormation create stack command creates the stack and deploys. If validation passes and nothing causes the stack creation to roll back, so proceed to the next step. Tips is to check the process of the stack creation. Navigate to the CloudFormation console in the navigation pane and choose stack and look for the status Athena query stack. All right. So to check the process of the stack creation, navigate to CloudFormation consoles. Let me navigate to CloudFormation consoles. In the navigation pane, choose stack. Let me see. CloudFormations stack right here. So we have it create here already. So it's verified. Confirm the name query resource that the CloudFormation was created. To verify the name query was created, run the following command in the AWS Cloud9 terminal. Okay, so this is what we have. The name query ID is unique identifier in AWS for the query that you created by using the CloudFormation stack. Copy the query ID to a text editor. So I'm going to copy the ID here to the text editor. Let's see, go over here. So save it here. So what we're gonna do now is so copy it to editor. To retrieve the detail of the name query, including SQL statement that is associated with it, run the following command. Replace the ID with the actual ID. Okay. So we copy the ID and we go to paste the ID back here. Where's the ID? The query ID. Here's the query ID. Run it. So this is what we have. Let me expand this. Awesome. Yep. The output is really similar to this. So to save the name query ID as a bash variable, run the following command and replace the query ID. Awesome. Confirm that the name query ID is stored as a bash variable and queue and run the following command right here. Good. The result is going to be similar to this. Awesome. So for task 5 summary, so in this task you learn how to integrate the Athena name query into the CloudFormation template. You learn how also to validate and deploy a template to create a name query in the CloudFormation stack. Many companies use multiple accounts with AWS to maintain separate development, testing, and the production environment. Isolating this environment helps to ensure the team follow the best practices, building queries in the development account and then testing them in the control account with a production data that can help to ensure that the query is designed as intended and generate the necessary insight. After validating the query, you can use DevOps best practices using CloudFormation to quickly move it to a production so that the appropriate business stakeholders can use it without having to build from the beginning. Now, task 6, reviewing the IAM policies for Athena and AWS Glue access. So now that you have created the Athena name query by using CloudFormation, review the IAM policies that the query that to ensure that others can use it in production. So note that the IAM policy for the query was created for you. You don't have to have the ability to create the IAM policies in the lab environments. So review the policies for data scientists, policy IAM. So in service, we're going to choose IAM, or if we already have it, we can choose it. Excuse me. We going to choose IAM. We all have in here in the cloud console management. So what we want to do is in the navigation pane, we're going to choose user. Here is user, and then notice that Mary is one of the IAM user in the list. This user is part of the data science group IAM group. So choose the username link for Mary. So click into Mary, we are in. On the permission tab, choose the link for policies for data scientist policy. Permission task, right here, policy for data scientist policy. We are in. The policy for data science details page open. Review the permissions that are associated with these policies. Notice that the permissions provide with limited access for only Athena, CloudFormation, Cloud9, AWS Glue, and Amazon S3 services. So let's go check it is. So here is the only things that are services that are allowed in this policies for data scientists with Athena, CloudFormation, Cloud Sales, Glue, and S3. Awesome. So task 6 summary. So in this task, you review the IAM policies for the data science group IAM group. The policy contain permissions for limited access to Amazon S3, AWS Glue, and Athena. The policy is attached to the IAM group that the Mary IAM user is associated with. The policies allows her to list name queries. The policies also includes the following permissions. For the Amazon S3, access bucket, list bucket content, and read and write objects, but not create a bucket. For AWS Glue, create the databases and tables within the database. For Cloud Cell, use Cloud Cells, for example, issues AWS CLI commands. For the CloudFormation, create stack and validate templates. For Athena, create a data catalog, create and get name queries and start queries. The policies could be used as an example policy for users who intend to create and use Athena queries and views with a dataset by loading it into AWS Glue database. As with all services in AWS IAM, users must have the appropriate permissions applied to be able to perform actions. So to task 7, confirming that Mary can access and use the name query. Now that you have reviewed the IAM policy, you will use it to test another user's access to the name query and their ability to use query in the AWS CLI. So retrieve the credentials for Mary IAM user in the search box service. We're going to search for CloudFormation. So now I would open a new tab. In the go to the AWS management console. Put it here in second tab. I'm gonna choose CloudFormation, check CloudFormations, and then go to the navigation pane and choose stack right here. And then in here, choose the link for the stack that created the lab environment. The stack name include random strings and letter and numbers, and the stack should have the oldest creation time. Which one I have the oldest creation time? Let's see. So this one should have the oldest creation time, so I'll click into that one. All right. So choose a link stack that create the lab environment. The stack name include the random string and number, and the stack should have the oldest creation time. On the stack detail, choose output tab. Output right here. Awesome. Note that when you create a CloudFormation template, you can choose to output information about the resources that the template will create. The CloudFormation template that created the resources in your lab environment output the access key and secrets key for Mary users. Copy the value of the Mary access key to your clipboard. So this is Mary access key right here. So I'm going to copy it. What I'm going to do is I'm going to save it in my text editor as well, just in case. And then what we're going to do is return to AWS Cloud9 terminal. Our Cloud9 terminal, where is it now? Cloud9 terminal is in here. Awesome. So what we'll do next is return to the Cloud9 terminal to create a variable for the access key. Run the following command and replace our access key. So AK, we have access key, AK assigned to our access key. Enter it. Awesome. Then return to CloudFormation console and copy the Mary secret access key to your clipboard. I go to the CloudFormations, Mary secret access key. Mary access key and Mary secret access key. Wait. Let's see. This is Mary access key. This is Mary secret access key. Awesome. So SAK. Go to SAK. SAK. Assign to this access key right here, secret access key. Awesome. Is done. Now test whether Mary user can perform the get name query command. You can pass the user credentials as bash variable AK and SAK with the command. You will also use the bash variable NQ to include the name query ID. The API will then try to perform that command as the specified user. To test whether Mary can use the name query, run the following command right here. Awesome. It's running, so the output is similar to the following and look like that the output was displayed after you ran the earlier command. We have name query, name description, database, query strings, and a name query ID and work group in here. So the result confirmed that Mary has access to the name query that you created and deployed by using CloudFormation. So for task 7, some summary. Congratulations, you learned how to create an Athena name query by using CloudFormation and to deploy it to user with a secure IAM policies. Because the query is in the CloudFormation template, you can use the template to create and deploy the queries in any AWS account and change the parameters as desired. Update to the team, so the team is happy that you all have learned and demonstrate by using Athena, AWS Glue, and CloudFormations. So that's it for this lab today. Thank you so much for watching till the end. I hope you have a great day. Thank you. Bye bye.